Okay, so we have two problems here. I'm going to work through with you guys. Give you some tips along the way if you need these. See if I can do it skillfully. So I had this first one. I have 7/8 plus 1/12. Now remember, with fractions, when you're adding or subtracting fractions, you need to find common denominators before you can solve the problem. So I have to find a number that is 8 and 12 can both go into. So what I'm looking for is the lowest common multiple, least common multiple, all right? Now, you don't have to find the lowest common multiple. You can just find any number at all that they both go into. So you could always just multiply the two numbers together. If I multiply 8 times 12, you can use a calculator. I'm pretty sure that's 96. I know that they both go into 96. So that would work. But if you do that, if you just multiply them out and you get a big old number like 96, you can solve the whole problem. And at the end of the problem, you're probably going to have to reduce. You're going to have to simplify the fraction because you use such a big denominator to start with. So it's a little more skillful if you can figure out a number that's smaller than multiplying the two, that they both go into. So I always do is you start with the bigger number, 12. We know 12 goes into 12 one time. Does 8 go into 12? No. So then you double 12, 24. We know 12 goes into 24 two times. Does 8 go into 24? Yes, it does. It goes into 3 times. So 24 is a number that both of them go into. That is going to be our lowest common multiple. So that would be a great number to use as a common denominator. So here's what I'm going to do. I'm going to rewrite this problem vertically. It works a lot better that way. So I'm going to have 7/8 and I'm going to have 1/12. And then I'm going to find equivalent fractions. I'm going to find fractions that are equal to these, but they have different denominators. And I want to choose 24 as my common denominator. So what I'm trying to figure out now is, what did I multiply 12 by to get to 24? Well, I multiplied it by 2. So since I multiplied the denominator by 2, I have to multiply the numerator by 2. Why? Think about this. What is 2 over 2? 2 over 2 is nothing more than 1. It's a different form of 1, but it's 1, right? 2 over 2. So what happens when you multiply any number by 1? You get the same number again. So therefore, 2 over 2 times 1/12 equals 2/24. But this is really just 1 times 1/12. That's why these two fractions are equivalent. They're really the same thing. They're just different forms of 1/12. Now the same thing with 7/8. This time I'm going to multiply by 3, because 3 times 8 is 24, 3 times 7 is 21. Therefore 21/24 is really the same thing as 7/8. Now I can add because I have common denominators. So you add the numerators. 21 plus 2 is 23. Voila. And look at that, beautiful. I don't have to reduce it. It's all done. If I had used 96 as my denominator, I would have had a much higher numerator, and then I would have to reduce it. So hopefully this rings a bell for most of you guys. Let's try one more if you need it. If not, you're good to go. Just start working the problems. So I'm going to start by writing it vertically. 4/5, 2/3. Remember, it's a subtraction. I have to find a common denominator. 5, I'm going to start with a 5. Does 3 go into 5? No. So I'll double 5, 10. Does 3 go into 10? No. Triplet, 15. Yes, it does. Both of them go into 15. What did I multiply 3 by to get to 15? Well, I multiplied it by 5. So therefore, I must multiply the 2 by 5 as well, because I want to multiply by 1. 5 times 2 is 10. So 2/3 is really the same as 10/15. And then I'll multiply the same thing here. 3 over 3. 3 times 5 is 15. 3 times 4 is 12. So now I can do the problem. 12/15 minus 10/15, 2/15. So when you're adding and subtracting, once you find the denominator, common denominator, you just bring the denominator down, and then you just go ahead and do the arithmetic with the numerators. So far, so good. And then, of course, they can be trickier. You know, you can trick these problems out by making the numerator, the first one, smaller. Let's say I made this, just for argument's sake, let's say I made it 8/15 minus 10/15. Then now you're working with integers, right? 8 minus 10, -2. So what? No big deal. Or let's say when in the addition problem, if I made it 21 over 24 plus 7. Let's just pretend this is a new problem. 21 plus 7 is 28. Now, what's that? What happens when you have a number on top that's bigger, the numerator is bigger? That's called an improper fraction. Now, you could leave it like that, just kind of look at the answer, or typically you would make that a mixed fraction. So then you would say, okay, how many times is 24 going to 28? Once. So I'd pull out a whole out of that 28. I'd pull 24 24ths out of that. And then I'd have how much would I have left over? 8 minus 4 is 4 24ths left. And then I could reduce 4 24ths. 4 goes into 4 once. 1 and 1/6. So that's a little bonus. Hopefully I didn't throw you guys off and confuse you too much. You can follow along with that. What's important for this little mini lesson is just common denominators. Once you have that, then just add or subtract your numerators. Any questions? Let me know.